Let's look at the examples for chapter 5. We're starting with true and false questions. For the first one, rating the satisfaction of a hotel room on a 1 to 5 scale is an example of a discrete random variable. This is true. The amount of soda consumed by an adult next month are an example of a discrete random variable. That is false. It can be any amount, so it's continuous, not a discrete random variable. The mean of a discrete probability distribution is a weighted average of the outcomes of the random variables that comprise it. That is true. The equation used to calculate binomial probabilities relies on permutations of n objects selected x at a time. This is false. In a binomial experiment, the number of successes can never exceed the number of trials. Absolutely, this is true. The number of typographical errors found in a manuscript would best be described using a Poisson probability distribution. That would be true. Multiple choice questions. Which of the following is not a condition of discrete probability distribution? The correct answer will be B. The probability of a success must exceed the probability of a failure. Again, it's not. That's not a condition. When the discrete random variable is expressed in terms of dollars, the mean of the distribution is known as the expected monetary value. The correct answer is D. A novel on Amazon.com has the following ratings in numbers of stars from reviewers. Calculate the mean of the distribution. So we have X and we have the frequency. So that means that I need to calculate the f of x. So this is your frequency. And we will need to calculate the probability for each outcome before we are able to find the mean of the distribution. So what do? We simply calculate the relative frequency of each outcome. That means I need to find the total, which is 50. You take, for each outcome, the frequency over the total number. So you will have 7 over 50, which is 0.14. Then you have 4 over 50, which is 0.08, and so on and so forth. So you have 0.08, 0.4, 0.18, 0.2, and then you take x times f of x, or p of x is the same thing. You take the product of these two columns. So you will have 1 times 0.14, 0.14, 2 times 0.08, that will be 0.16, 3 times 0.4, 1.2, 4 times 0.18, 0.72, and 5 times 0.2, that would be 1.0. So we add them all, and this will give us 3.22, which is our average. Therefore, the correct answer will be 3.22. The mean and the variance are equal for the which probability? That would be the Poisson. This is one of the main properties of the Poisson distribution. 77% of husband-wife families with kids under 18 years old have life insurance. A sample of 6 husband-wife families were selected. So automatically you know that this is your P. P is equal to 0.77. and this is your n is equal to 6. What is the probability that exactly 4 families have life insurance? This is binomial probability distribution. You're looking for x to be equal to 4. That means binomial PDF n, comma, p, comma, x. What is x? What I'm looking for, you do your calculations and you will get A. For the same example, which means P is equal to 0.77, N is equal to 6, what is the probability that less than 2 families have life insurance? So once again, binomial probability distribution. Less than 2 means probability of x equals to 0 plus probability of x equal to 1. So you will do binomial PDF n comma p comma x plus binomial PDF 6 comma 0.77 comma 1. Once you do your calculations, the correct answer will be A. What is the mean of the distribution? For the same example, I'm looking for the expected value, the mu. For this type of distribution, you simply take n times p. N is 6 times 0.77, and the correct answer will be 4.62, since we have binomial probability distribution. A company, problem number 8, multiple choice question 8. A company that bakes chocolate chip cookies averages 5.2 chocolate chips per cookie. Assume that the number of chocolate chips per cookie follows a Poisson distribution. What is the probability that a randomly selected cookie will contain 1 or 2 chocolate chips? The only information given to us is the average. We are informed that we have Poisson distribution. Lambda is equal to 5.2. I'm looking for the probability of x to be equal to 1 or x to be equal to 2. So we will do Poisson PDF L, comma, x plus Poisson PDF L, comma, x. We'll do Poisson PDF for each one, and then we will add them. You can also do it at the same time when you do your calculations. So second vars, you go down to binomial PDF, second vars, we are Poisson, not binomial. Hold on. We have 5.2 comma 1, you close parentheses, and you go plus second vars, binomial PDF, Poisson PDF, enter, 5.2 comma 2, close parentheses, and enter. So the answer will be 0.1033. So instead of doing it separately and then adding them, you can just do it all at once. So the correct answer will be B. Dwight Howard has an average of 1.8 blocked shots per game. Assume that the number of blocked shots follows a Poisson distribution. That means that lambda is equal to 1.8. What is the probability that Howard will block 2 or 3 shots during the next game? So I'm looking for the probability of x to be 2 or x to be 3. So we will do Poisson, same way, PDF, 1.8 comma 2 plus Poisson 1.8 comma 3. You do your calculations and you will find this to be equal to 0.4285. So let's look at the problems. The following table shows the number of used cars sold each day over the last 25 business days at Newark Motors. You have the frequency and you have the number of sold cars. We create the following table. First, we need to find the probability. How do we find the probability? Because we are not given the probability, we're simply giving the frequency. You add them all, you know that this is 25, so you calculate the relative frequency for each outcome. So for the first one, you're going to do 6 over 25, the second one 2 over 25, and so on and so forth. So let's go to this table where I have them written down. You have your x, and this is your p of x, or f of x is the same thing. This is your probability. You want to find the mean number of cars sold per day. That means you are looking for the expected value, your average, and in a discrete probability distribution, you find the average by taking the sum of x times p of x. So all I need to do is multiply these two columns as I did here. So this is going to be 0, this is going to be 0.08, this is going to be 0.4, 0.36, 1.12, and 0.4. At the end, we add them all, and this will be 2.36. So this is equal to 2.36. This will be the average number of cars sold per day. Now, what is the standard deviation for the number of cars sold per day? For the standard deviation, this is your sigma. To find sigma, I first need to find the variance. So first, you're gonna find the variance, and then you will take the square root of the variance to find your standard deviation. So that means I need to create an additional column where I take the square deviation of every entry from the mean and I multiply it by the corresponding probability. And this is what you have written down here. This will be 1.337. This will be 0.148. This is going to be 0.026, 0.049, 0.753, and 0.558. We add them all, and this will be 2.871. So sigma squared is equal to 2.871. This is not your answer to the question. To find the answer to the question, you will need to get sigma. Sigma is the square root of your variance, square root of 2.871, which is 1.694. And this is your answer. Now, what is the probability that x will be more than 2? All right. So more than 2, if you look here, you're interested in these outcomes, 3, 4, 5. So all you really need to do is add the probability of each of these outcomes. So this will be equal to the probability of 0.12 plus 0.28 plus 0.08. This probability will be 0.48. So greater than 2, you take the probability of x to be 3, 4, and 5, and you add them. For problem number 2, Kobe Bryant, a professional basketball player in the NBA, has made 84% of his free throws during his career with the Los Angeles Lakers. Calculate the probability that Bryant will make 4 or 5 of his next 6 free throws. That is, if he was still playing, right? So let's look at this. We have P right here to be 0.84. Find the probability that he will make 4 or 5 of his next 6 free throws. So this here is your n. N is equal to 6. So I'm looking for the probability of x to be equal to 4 or x to be equal to 5. So this will be equal to the probability of x equal to 4 plus the probability of x equal to 5. You will do binomial n, comma, p, comma, x for each one, and then you will add them. 6, 0.84, 5. So once you do your calculations, let me just show you an example. We will do second vars, binomial PDF, 6, 0.84, 4, close parentheses, plus second vars, binomial PDF, 6, 0.84, 5, close parentheses, enter. So the answer will be 0.593 if you were rounding to the third decimal, 0.593. Calculate the probability that Brian will make 6 out of the next 6 free throws. So I'm looking for the probability of x equals to 6. That means binomial n, which is 6, 0.84, 6. So this will be equal to 0.351. Calculate the expected value and variance for this distribution. We have a binomial probability distribution. The expected value, the mean, is equal to n times p. N is 6 times 0.84, which is the probability. This will be equal to 5.04. And for the variance, sigma square is n times p times q. N times p times q is equal to 1 minus p. N is 6 times 0.84 times 1 minus 0.84, and this will be equal to 0.806. According to the U.S. Census Bureau, 66% of the American adults owned their own homes last year. So this is your P. P is equal to 0.66. A random sample of 7 adults was selected. What is the probability that exactly 3 of them own their own homes? Exactly 3. I'm looking for x equals to 3. All I need to do is plug in the information. Binomial 7, 0.66, 3. So this will be equal to 0.135. What is the probability that more than 5 of them owned their own home? So I'm looking for x to be greater than 5. X greater than 5 means probability of x equals to 6 plus probability of x equal to 7. Why am I stopping at 7? Because I can only go up to the sample size. So I will do binomial PDF 7, 0.66, 6 plus binomial PDF 7, 0.66, 7. 0.028 plus 0.055. The answer will be 0.083. What is the expected value and variance for this distribution? The expected value expected value, E of x, this is your mu, is equal to n times p, 7 times 0.66, this is 4.62, and the variance, sigma square, once again, n times p times 1 minus p, so I have 7 times 0.66 times 1 minus 0.66, so this is going to be 1.571. For the next problem, according to a study, an average of 6 cell phone thefts is reported in San Francisco per day. Assume the number of reported cell phone thefts per day in the city follows a Poisson distribution. So this 6 is your lambda. Lambda is equal to 6. What is the probability that exactly 6 cell phones will be reported stolen tomorrow? So I'm looking for the probability of x to be equal to 6. We will do Poisson PDF lambda comma x. So Poisson 6 comma 6. So the answer will be 0.161. What is the probability that 4 or 5 cell phones will be reported stolen tomorrow? So I'm looking for the probability of x to be equal to 4 or x to be equal to 5, which means I'm looking for the probability of x to be equal to 4 plus the probability of x to be equal to 5. I will do Poisson for each one. Poisson PDF 6, 4 plus Poisson PDF 6, 5. If you do your calculations, again, second vars Poisson PDF, then you will get 0.134 plus 0.161, and the answer will be 0.295. What is the probability that no cell phones will be reported stolen tomorrow? So all I need to do for this one is calculate the probability that x is equal to 0. That means we will do Poisson 6, 0. Let's do this example. Second vars Poisson PDF 6, 0, close parenthesis, enter 0.0025 for the answer. A very slim probability of that occurring. Calculate the mean, the variance, and the standard deviation. Keep in mind that we have a Poisson probability distribution. I'm looking for the mean, the variance, and the standard deviation. In a Poisson probability distribution, the mean, mu, is equal to lambda equal to 6. I have that. For the variance, one of the main properties of the Poisson distribution is that sigma square is equal to lambda, which is equal to 6. And the standard deviation, sigma, as always, is equal to the square root of the variance, which in this case, square root of lambda, square root of 6, which is 2.45. And this completes the examples for chapter 5.